Hello and welcome to Maths with Jacob. This lesson will focus on reflection in a mirror. When I wake up in the morning and look in the mirror, it's not a pretty sight. However, when my face is reflected in the mirror serves a similar function to an axis of symmetry. Even though the image is reversed, it is a perfect representation of the original subject. We are assuming here that the mirror is normal and has no enlargement, reduction, or distortion properties. So, an axis of symmetry, sometimes called a line of symmetry, gives a reflected version of the original image. All distances from the line to each object are equal. That is, distances from the mirror or from the line of symmetry or axis of symmetry. Let's look at this little cat. See the reflection in the mirror there? Here's a beautiful flower. Reflection in the mirror. This is a little pussy cat standing on top of the mirror, and there's a perfect reflection in the mirror. And here's a picture of a person, and you can see the reflection in the mirror. The side view of reflected objects. Now here, the pre-image, that means that is the original image. That's the original one. This here, pretend that's the mirror or the line of reflection, and that's the image on the other side. This is very important here. The distances from the mirror to each image are equal. In other words, that distance there is the same as that distance there. This distance here is the same as that distance there, and so on for all points. Here are some letters that are reflected, and there's the letter C, and you pretend that's a mirror, and that's the image. Here's the letter N, the mirror, and the image. And there's the letter R with a mirror and the image. So if you have a mirror or a line, we can call it a mirror line if you want. There's the original shape and there's the reflection. And again, so important, that distance is the same as that distance. So it actually helps you to draw the reflection. That distance is the same as that distance. And that's why we can draw this reflection quite accurately on the other side. Now here, we're going to use that little rule about distances to try and draw the reflections on the other side. So for each of the following images, sketch the reflection in the mirror. So let's take this blue rhombus here. Now if we take that distance there, and let's pretend there it is there, that's equal. If we take that distance there, and let's say there. Now if you had a ruler and you were doing this on a piece of paper, this would be very, very, very accurate. So we can join that line there. So we definitely know that's true. So the distance from there to the mirror, let's assume it's about that far. Okay. I wonder if it's that far or a little bit further. That's good enough. And that distance there to the mirror, or that could be about that far. So look at this. There's our reflection. See that? This object is looking at itself in the mirror, and these distances here, if we measure them correctly, are all the same. Let's look at the triangle. Here is the original shape and the reflection. So we need that distance there to be equal, and let's say that's close enough, isn't it? That distance there, what do you reckon? About, I'd say there. So that gives us that line. Okay. All we've got to do is find the last one now. So from there to the mirror, say we go there. As I say, if you have a ruler, you can do this perfectly. So how's that for a good idea of the reflection? See that? That's why we're sketching, because we can't get an exact representation, but on a piece of paper with a mirror, you can do this perfectly. Let's see if we can do the letter E. That distance is about there. This one here is about there. And this one here is about there. Now the length of the E, see if we can approximate that. That looks pretty close, doesn't it? So we come down here, we go across there, and there's our reflection, okay? This is a little bit of a tricky one. Of course, it's like an oval, isn't it? So we need, say, from there to there, what do you reckon, about here? That's pretty close, isn't it? From there to there, what do you think? That's not bad, is it? And then basically you can do that for a number of these lines going all the way across, but in the end we're sort of looking at something like this. Okay? That's not a bad representation, is it? And if you like, you can colour it all in, and that gives you a really good idea of the reflection. So just forget about that bit. So the important thing to remember is it's all about distance. That whatever point you pick on the original shape, as you go across, the distance is the same in the reflection.